Let's talk about improper integrals that have infinite limits of integration. Suppose I want to integrate from 1 to some point b of f of x is 1 over x squared. Now, I'll just simply write this, the integral from 1 to b of 1 over x squared, and I can do that limit quite easily. But what if I want to look at the limit as b goes to infinity? All right, this area is the unbounded region between f of x is 1 over x squared from 1 to the right, or from 1 to infinity. Now, you can't just shove infinity in there. It turns out what we do is we have to rewrite this. If we want the integral from 1 to infinity of a function, then we take the limit as b, where b is our dummy variable. That becomes our upper limit of integration. The limit of b goes to infinity of our function. And after you do the integration, then you apply the limit. Now here are some general guidelines. The integral from a to infinity of a function is the limit as b approaches infinity of the integral, the definite integral from a to b of f of x. Now, this converges if the limit exists. It diverges if the limit does not exist. If I want to take the limit as x approaches negative infinity, then we take the limit as a approaches negative infinity of a to b of f of x dx. And the same guidelines apply. If I want the limit from negative infinity to positive infinity, then just pick some random number between negative infinity and positive infinity. 0 is usually a really good number. And the limit as, and we'll then integrate from negative infinity to that point c of f of x dx, plus the integral from c to infinity of f of x dx. Now, this converges if both of these limits converge. You have to apply the limit here, and it diverges if one or both of these diverge. Let's look at a couple of examples. What if I want the integral from 1 to infinity of dx over x? Well, I know I can't just do this, so I'm going to write this as the limit as b approaches infinity of the integral from 1 to b of dx over x. So this is the limit as b approaches infinity. Now, the integral of x, dx over x is natural log of x evaluated at 1 and b. So this is the limit as b approaches infinity of the natural log of b minus the natural log of 1. And this, of course, is positive infinity. So this diverges. Well, let's look at this one right here. The limit as x approaches, or the integral from 0 to infinity of e to the minus x dx. Well, I'm going to let this equal the limit as b goes to positive infinity, the integral from 0 to b of e to the minus x dx. So this is the limit as b approaches infinity of minus e to the minus x, evaluated at 0 and b. So it's the limit as b approaches infinity of minus e to the minus b minus e to the 0. Now this limit, this goes to 0, this goes to 1. I've got a negative sign, so this is 1. What about the limit as x goes to infinity, or the limit from 0 to infinity of 1 over x squared plus 1? Well, again, we're going to rewrite this as a limit as b approaches infinity of the integral from 0 to b of dx over x squared plus 1. Now we know this is the arctan of x, evaluated at 0 and b. Now, this becomes the limit as b approaches infinity of the arctan of b minus the arctan of 0. So that's 0. This term right here is pi over 2. You always take the first one, the principal one.